Today we have the oral exam for the computer graphics course. For those who are not part of the class, you're going to see teams are going to be presenting their work on their final project. So without further ado, the stage is yours.
All right, my name is Yves, this is Julie, and our project, we did a game of disc golf. So, just to introduce, because not everyone knows what disc golf is, it's pretty much like golf, except you use like a frisbee, like a flying disc, and what you have is you have baskets that are located in various areas, and you also have a par, so that's the average number of throws it will take, and your aim is to throw the disc into the baskets in as few throws as possible. And we actually have a course here in Odell Park that has, I believe it's 9 baskets, and yeah, it's pretty fun. We programmed our project, and like we only used WebGL, we didn't use anything else, using the JavaScript API and HTML5. So with modeling some of our objects. So we based our project on the Lab 5 that we did in class with the room with the table and the cube. And so we took the same draw cube method from that to draw our scene, our room, I guess. And the tricky part was to figure out how to draw a cylinder. And to draw a cylinder, we took the draw cube method and we modified it to add more sides, kind of. Essentially, we don't have a perfect cylinder, it's an octagonal prism. And what we did is, so we have eight sides, and then say, another 8 sides. So we drew those using triangles with the center point, and so on. And then with that, we have that at, say, z equals 1, z equals -1. And so then we just connected those, and these sides each had 2 triangles. And so on around. So that was our cylinder that we made. 96 triangles. And so that was the basis, and that was how we made our disc, basket, trees, clouds, kind of everything. And yeah, so the cube and the cylinder allowed for us to model those. And as well, we had some modified shapes as well. We had an arrow for the wind. In our game, we have a random wind vector that's generated on every throw. And we modified the cube method to add like a at the end of it, and so you'll see that just like floating in the air. And we modified the cylinder to also have a little point, and that shows you where you're pointing the disc.
So with our shader, we have like huge shader for the cube and the cylinder, because like the way it computes the normals for it is different, so that's why we decided to separate them. And as you can see here with the cylinder, like this side, since it's connected with all the on these points, when we use like the same shader on the cube, it's taking the normals of these points instead of having like their own normals pointing up. So that's why we separate them, and we also have a procedural program for the computation of the normals for the shaders. So if we set like the normals for this 0, and they'll compute it on the shader. We didn't like implement it for the functions and chemistry. And also for the lighting, we have like we make it like it follows the camera. So if you rotate the camera around the area, you'll see that it follows the light. And also we have like specular direct like specular lights, ambient light, and diffuse light implemented there. And for our shadow, since we kind of having trouble to implement it on the shader, we just project like this on the ground, and it follows the cylinder's movement.
Okay, so just a bit about the mechanics of the disk. So we have position, velocity, and acceleration that are changing with the disk, and our acceleration includes three components. We have gravity acting down upon it, wind, just the random wind vector that's generated in any direction, and wind resistance or drag that will slow down the disk. So those are incorporated into the acceleration, which, so our velocity is dependent on the acceleration, and position is dependent on the velocity. And then collision detection, I guess.
Yeah, so we base it on the size of our cube, but since we didn't show like all the sides of the cubes, but it detects like the upper part of the cube, which is like it's negative, it's 2 to -2, so it detects all the edges, and once it's touched by this, it will start, it will go to a starting point. And also the arrow. For our arrow, you'll get a force on that, and also added to the physics, the position, and like it takes the last scaling, let's say scaling factor on that, and added to the acceleration computation. And also we have like two objects, elements. So for our heads-up display, we use that for our 2D objects, so you can see that you return like player scores and status. And also for the canvas, that's where we use the 3D object, so we project there. So it has 2 layers, and like the heads-up display is one layer up on the canvas. And for our gameplay, we have 2-player mode. So since we were kind of alternating turns, we have separate function for each player. So they don't really we don't use like separate computation for the speeds and this, but the position, how it computes the last position for each. We have to separate it, because if we put it on the same function, they'll move like at the same time, taking everything. And also we have the status bar, and it's on the HUD, so it'll display if you hit an edge, you score, or like it's which player's turn it is. And for the mouse control, we have two separate controls for the camera and the vectors for the physics. So our left click is for the speed, like all the acceleration stuff that's happening on the cylinder, and on our right click, it's for the camera movement. So if you went far on the Z axis, you could rotate it rotate the camera to see the list and point on the direction you want. And also we use like key press for the toggle. So if you want to display the instruction, you just press C and it'll display the instruction for the game. And we also added the audio elements for it. It's on the HDMI. We just added it. Also, every time you throw the disc, you'll hear a sound like swoosh sound for it.
All right, so let's try this out. So I know it's kind of messy here, but this is what it looks like when you first start the game. You can see on the, can everyone see that? Should I turn on? You can see when you start that all your elements on your HUD, like whose player turn it is, what throw number you are, kind of at the corner there, what hole you're at, what the par is for the hole, your instructions here. Over there it says press C to toggle instructions. So if you, obviously you want to get rid of that, so let's do that. And then this is your status bar, kind of saying whose turn it is, and if you hit something, it'll tell you hit something. If you win, that's when you win, and then the scores. So we can explore again, like Julie said, with the right click, you can rotate around and just see if say your disc lands somewhere way over there, you can like rotate it and find your disc again. The camera follows the disc, but sometimes it just goes way off. And when you on your left click, that controls your arrow, and so it controls where you want to point the disc and where you want to shoot it. And as long as you're holding it, it'll keep increasing and decreasing in magnitude, which is a representation of how much force you're applying on the disc you're throwing. And so you can see that wind vector. That wind vector is pointing that way. So you want to point it somewhere in the opposite direction to kind of counteract the wind. And again, the wind will be randomly generated every time. For people who are maybe like, the arrow is kind of a nice visual, but there's also a numerical representation of where the arrow is going to end up to, like X and Z. It's hard to see there, but so yeah, we can see it's status player's A's turn, so you can do something like you want to point it that way. See how this goes. So, and then now it's player B's turn with the red disc, and then status as player B's turn. Player switches to B, it's throw one for player B, and then you have your red arrow.
Your player B again? We should compete against each other.
Okay, so we player B.
Let's see who's better.
Okay. So since the wind vector is pointing in this direction, so you want to
Yeah, just defeat him though. You don't have to explain how to do it.
opposite.
Oh.
I hit the edge.
See, she hit the boundary. She hit like the
I did that
edge.
on purpose to demonstrate the edge.
And so it tells you player B hits the boundary, try again, and it doesn't count as a throw because if people keep messing up, we don't want them to be like 100 steps away from the basket. So Julie can try again.
It's my turn again.
And again, there's another randomly generated wind vector.
Oh.
I don't know how to do it.
It's tricky because sometimes you don't realize how much
Um,
power the wind is going against you. So if you're pointing somewhere, you're gonna have to really kind of exaggerate maybe where it's headed. I overshot that one.
And we also have like 3 collisions, so but we only did that on the leaves. So if you hit a tree, it'll bounce back.
So I don't know if I want to keep going.
How did you make the clouds?
It's with the cylinder.
There's some
There's cylinders?
flat cylinders
Oh.
on each other. And
We just scale it on the different axes.
we kind of made it kind of really arcade looking.
It looks cute.
Our trees are flat. Our basket is consistent of 3 cylinders,
Yeah.
various
Mostly
widths.
it's all cylinders.
Yeah.
Are they trees or lollipops?
So it's trees.
We did like the noises on the mouse, but it doesn't look that good, so we removed it.
Oh yeah, we tried grilling noise, but it didn't turn out.
Just put some randoms.
No, if you paint everything red and with white stripes, they can be candy actually. So you can have this gold thing,
Candy
the
man.
candy tree, candy forest.
Different levels, you know. For now, we only have the one pole, and when you win, it's like the game's over.
And sugar clouds. It can be extended.
Cotton candy clouds.
Yeah, candy.
Yeah. So
How did you split the work, guys?
pretty evenly. At first, we took the lab and we kind of, our first thing to do was to build a
Just
cylinder.
cylinder.
And we worked together, took a lot of time to work that out, but then once So we got that. Julie kind of made the trees, the basket. We worked on different things. I made the wind vector, kind of some of the HUD elements. Julie made like gameplay elements. I kind of figured out some of the mouse controls. We added audio.
Your code also captured like how the physics and that you work together. Like that's like time. A lot of time is spent.
Yeah, that was pretty time-consuming.
Do you think we can sell it and make some money?
We
Maybe you should look into that. Guys, any questions for this Go team?
Did you guys run into any like performance issues? Because you have so many triangles and stuff.
No, not really. Well, like, no, we like worked on the computers upstairs a lot, and they were fine. We didn't run into it. Yes.
When you're throwing the disc,
Yeah.
is it throwing it along a sort of a 2D vector, or is it throwing it along a 3D vector?
We're converting the axis to a square coordinate. Like if you capture, like it'll capture the last location of your mouse and convert it like a square coordinate, and then apply the other acceleration.
Yeah, spherical coordinates takes like the sine and cos of the triangle, and that's what it means. 3D vector.
Any more questions? Okay, thank you very much.